Hello again, everyone. Let's talk about Tech Math 1, chapters 11 and 12. I don't know how I wrote 13 when I meant 12, but we got, again, Tech Math 1, chapters 11 and 12 review. Let's solve some of the problems. I'll put it on pause a little bit and kind of set up other ones. I think it might be more efficient for you guys when we're doing this stuff. There's 180 degrees in a triangle. 180 degrees in the triangle. Therefore, this one right here and this and that, when added together, is 180. 25 degrees and 82 degrees is 107 degrees. You need another 73 degrees to get the 180. So that is your answer. Same situation going on here. That's a 90-degree angle. That's a 39-degree angle. That's 129 degrees. 90-degree angle and 39-degree angle, 129 degrees total. What is left to get, what would you add onto 129 degrees in order to get 180 degrees? 51 degrees. So the answer here, 51 degrees. The two questions being asked for problems 1 and 2 are find angle A and find angle B. And we just did that. 3, triangle ABC. Triangle ABC is an isosceles triangle. Sides AB and AC are equal. Find the angle C right here. Well, I tell you what, if it's an isosceles triangle, these are congruent to one another, then the angles associated with the isosceles aspect. Isosceles itself is a fascinating term. Isosceles. It's a fascinating term. Hopefully I spelled it right. Iso, isa, είμαστε ίσα. Isa in Greek mean we're equal. This right here, I guess if you put a K, because the C and the K can make similar, put a K in place of that, skeli. In ancient Greek, legs were called skeli. Legs were called different things, pod, podi, foot, whatever, but skeli looks a lot like the word, skeleton. Frame on that, kind of neat. Anyway, if this is an isosceles triangle, the angles associated with the equal length sides are themselves equal size angles. So the angle opposite each of the isosceli part of the triangle, the angles opposite each of those sides are congruent to one another. So if this guy's x and this guy's x, then x plus 64, x plus 64 is going to give you 180 degrees. Subtract 64 on each side, and you get 116. X and x is 2x. Divide by 2 on each side. You not only found one, you found both. This right here is a 50, forgive me, that's actually the wrong answer. That should be when you divide by 2 on each side, should be 58. So what we have here is 58 degree angle, and we have here is 58 degree angle for both of those. They only wanted one of them. They wanted angle C. But what the heck? I mean, we got this. They are congruent to one another, and we got that. Okay, number 4. Find H round to tenths. Well, this is an isosceles triangle. In fact, it's a special kind of isosceles triangle called an equilateral triangle. This thing comes right down here and cuts this thing in half. This is 12, this is 12. Okay? So this is 12, this is 12. 24, 12, h. How are you going to do it? Well, I'll tell you what. Call this longest side c equals this. Call this guy b if you want. And call this guy c. Call this guy a, rather. I'm sorry. So we know that c squared equals a squared plus b squared. We know that. We know a lot of things. Now, well, what we don't know is b. B is equal to h. Let's solve for b. So if you're looking at something like this, you guys, take a look at this as is right now. You're going to solve for b. Subtract a squared on each side. B squared equals c squared minus a squared. B we said is equal to h. So if b is equal to h squared equals c squared minus h squared. Square root both sides. H equals the square root of c squared minus a squared. H equals, c is 24 squared. C is 24, you're going to square it. A is equal to 12, square it. And let's see what we can say. 24 squared, 24 squared is going to be 576. 576, 12 squared is 144. 576 minus, 576 minus 144 is going to be 432. The square root of 432, let's take a look at it. .7846. Let's see here. Right. 20.7846. So 20.7878 rounds up to here. And we got that. H is 20.8 meters. Let's just make sure. Like I said, there's some stuff I did here in my head a little bit. So let's, right, 20.8 meters. That's fine. Here we go for number 5. Now this chalk is wonderful chalk, but it does expire relatively quickly, I guess. You can put a lot on here and get a lot done with it. Let's see how this all plays out. We will take, let's just take a look here. Got that. Looking something like that. Let's see here. This is kind of like, this is the hypotenuse. Call it C. C squared equals a squared plus b squared. And we do go into extensive coverage of what that means. If C is equal to J, if this is going to be equal to, you can call that one A, you can call this one B, it doesn't matter. As long as you call the long one C, you're probably okay. And you say, okay, well, I don't know what C is, so I don't know what C squared is. I do know what A is. And I do know what B is. So C squared equals all this. 55 squared, whatever that's going to be, and forgive me 1 second here. Yes, that was correct. I was kind of looking over that one more time. Look at this one, 55 squared. That's an interesting rendition of how things get done. If we can do some of this in our heads. The quantity 55 squared is the same as the square of the product 5 times 11. 5 times 11 is 55. If you square the product, 5 times 11, it's 25 times 121. 25 times 121 is 2,000, forgive me. No, it is 2,500 plus, let's see here, 2,500, 3,025. 40 squared is 1,600. Add them together, and we get 4625. Square root both sides. Again, when you do that, you square root both sides, and you're going to get the answer that you need. Let's just make sure. Again, a lot of this I'm trying to do relatively, somewhat quickly, I guess you could say. 4625, 68.00735. Let's have a look. Round to tenths. 68.00735. I'm guessing 68.0. Now, again, let's just make sure it's right. I mean, I'm trying to do some of this stuff in my mind. I think it's right. But let's try to verify that. That's problem number 5. You can see that in the actual answer key. 68.0 meters, absolutely. Okay, 68.0 meters is C, and that's the same as J. Okay, very good. What we can keep saying is, let's get over here. Let's call this guy C, let's call this guy A, call this one B, and let's go C squared equals A squared plus B squared. I want to solve for B. Let me subtract A squared on each side. Let me square root each side. You cannot take shortcuts. Guys, I've already said that. You can't square root C squared and call it C, and then square root A squared and call it A and think, oh, C minus A. It doesn't work that way. You've got to evaluate exactly what this is, then go for it from there. Equal to F on this one. One more time here. C is 16. 16 squared is an interesting matter. It should be 256, but let me think about it for a bit. Yeah, I'm going to say it's 256. So 16 squared is 256, and 14 squared is 196. Add these together, you get 452. Yeah, you add these together, you get 452. Get the square root of that, and let's see to what level they want that answered. Round to hundredths. So you take 452, (21.26029). Absolutely. 21.26 for number 6. Okay, there seems to be something that I add the 2, and of course I did add the 2, which was not one of the more intelligent things that I've done today. That's okay. We're not done. Let's try it one more time. Let's do the subtraction here. And I guess it would help if I'm going to say do the subtraction, then actually write subtraction. Let's do the subtraction here, and you get not a very big number, which makes sense. And so what we have here, when you actually do the subtraction here, you're getting 60, I think. It's just right on the bat, man. The square root of 60. So all right, let's take a look at that. It's going to be more than 7, but less than 8. 7.7459. Well, 7.745 rounds up to 7.75. Okay, sorry about that, guys. We'll always try to catch it. And again, we always meet in class as well, so we can correct anything if there's something that's going to go wrong, but it does happen sometimes. Try not to. I mean, there's literally hundreds of problems here over the course of 8 review exams. So hundreds of problems, yeah, there's going to be a misstep every now and then, but okay. We're okay. We're doing okay. So we got to here, and that's looking good. So let's look at 7. Let's look at 7. Now, 7's a neat one. Find the area of the figure to hundredths. There's a lot going on here. Well, some things are easy, some things are hard. You got to find out how tall this thing is. When you find out how tall that is, you can multiply it by the base. The base is 10.82. Half of 10.82 is 5.41 here, and it's 5.41 here. True. Find out what h is. Well, this is an isosceles triangle. Don't have to worry about that quite as much. If I got 10.54 right here, and if I got 12.84 right here, finding h is basically, we remember that c squared equals a squared plus b squared. Let's call this a. Let's call this c. Let's call that b. And we'll take it from there. This is also a. Not really important. 2a makes the whole thing. That's this whole thing. That's this. Okay. We're going to solve for b, which is the same as h. We're going to solve for b, which is the same as h, so let's just deal with it. Let's take and subtract a squared on each side. Let's then square root each side. H is going to be equal to this. Sounds good to me. H is going to equal the square root of this difference. We got 12.84, that's the C. 12.84, that's going to be squared, minus 5.41. That's going to be squared. Okay, it's a little bit of a mess, and we got to be careful. But I think once we got the h, it's clear sailing. It'll be pretty quick. We're done in a couple minutes. Let's have a look. Let me take 12.84. Let me take 12.84 and square it. Let me subtract 5.41 squared. Then let me square root that. That should not have gone down like that, but it did. Okay, so there's no way that's true, what I just saw. Let's try it one more time. Let's go 12.84 and square it. Subtract 5.41 rather. Okay, that makes sense. Now, take that to the 0.5 power, or square root it. 11.64463. 11.64463. Well, I don't know how far they want to go with this. Well, I'll tell you what. Let me leave it long like that. That's inches. And let's try to just take this thing to the end. Now, I'm going to leave it like that for a reason, just to kind of cover ourselves. I'm never going to make a big deal if it's off. I mean, if they somehow made a different assumption, if they somehow made the assumption, let's just round it to the nearest whole number, that's 12, or the nearest tenths place, which is 11.6, or nearest hundred, 11.64. Well, I'll tell you what, I'm going to take it pretty far out like that, and let's kind of see what we can say. Just try to clean this up a little bit. For number 7, let's get the area. Let's get the area of the triangle above everything there. Everything, the thing that's above everything there is the triangle. And then let's get the area of the rectangle, and let's add the two areas. So here we go. We got over here for the 7, and the total area. Total area is going to be the area of the triangle plus the area of the rectangle. So the area total is going to be 1/2 base times the height for the triangle, and base times the other height for the rectangle. What are we talking about? Well, we're talking about 1/2. The base is this entire length right here, 5.41 plus 5.41, which is equal to 10.82. Yes, correct. That's this. The small h is this guy, which is 11.6446. We got that. The other one is the same base. The height is different here. The height is this guy, which is where we're getting this. So that's the height for that one, and this is the base for that one. This, it's the same base, but the height is different for that one. It's going to be that. Okay. So that height is going to be 8.47. Sounds good. There's a lot. I'm going to leave it like that, pretty far out like that, times 10.82 times 1/2, which is 0.5, equals this, plus 10.82 times 8.47. 154.6428. I'm going to say 154.64 for that one. Let's have a look. Yeah, there it is, 154.64 square inches. So a total .64 square inches Let's have a look just real quick. I'm sure it's right. I mean, we just saw it, but for number 7, 154.64 square inches. 154.64 square inches. That is it. And they were asking, like I said, the way they're asking it rounded to hundredths, we're okay. I mean, you know, there's pretty reasonable stuff here. Okay, guys, we're gonna do this again. I'm gonna put it on pause, put it, and bam, put some stuff up here again, and just start taking a walk through this stuff. All right, everyone, welcome back. Let's keep going. Let's look at 8, 9, and 10. They want you to define where this itself is C, the hypotenuse of a right triangle, and this is one of the legs, and this is another leg. And of course, the Pythagorean theorem is holding regarding that. We don't really need it here, but just for the record, we do see that it holds. C squared equals A squared plus B squared. How do you find the tangent? Well, the tangent, they're talking about vis-a-vis angle A. The way you do that is you go opposite over adjacent in this case. That is, forgive me, did it say B on that? It said B, forgive me. So we got B and A going on here. We got B initially going on. It is opposite over adjacent, that's B over A. Sine of A is opposite over hypotenuse, that's A over C, and that's A over C, and then for the cosine of A, that's adjacent over hypotenuse, that's B over C. So we have this, we have this, and we have this. Okay, so for the first one, second one, and third one. Okay. 11. Find side D, round answer to the nearest whole number. Well, this divided by that, D divided by 529, this leg divided by the hypotenuse, this leg divided by the hypotenuse is the leg that's opposite the 36-degree angle, divided by hypotenuse. Opposite over hypotenuse is the sine. To find D, multiply by 529 on each side. D equals 529 sine 36 degrees. Absolutely. Absolutely true. If that's true, the rest is the arithmetic that you're going to do. Plug and chug with the calculator, and let's see what we can do. So we got what we got. 529 times the sine of 529 times the sine of 36 degrees is going to be 529 times the sine of 36 degrees. They said round it to the nearest whole number. Well, okay, that's kind of interesting. That's going to play out. $529 times the sine make sure the mode's right, guys. Let's see what we got here. Okay, something's up with this. It might be some other mode going on here. Okay, guys, for some reason it's not giving me a good look here. I'm going to just make sure this is all correct. Every calculator is different, which always makes things a little bit interesting. Let us try to figure out what is going on here. That's radians, I think, for some reason. That's why I'm getting a weird answer here. All right, guys, for some reason, this is doing something very odd. See if it's doing it right now. Okay, yeah. Okay, very interesting how this whole thing plays out. The sine of 36, the sine of 36 degrees is 0.5877855252. Then I'm going to multiply that by 529, and I got 310.938, 3985. 310 and 310.9383985. So 310.938, they want it rounded to the nearest whole number. Well, to round it to the nearest whole number, you know where we're going with that, guys. So what's going to happen here is, does that stay at 0 or go up to a 1? We know what we're doing. So we got D is 311. End of the story. That's it. So what do we have here, guys? That was number 11. That's 311. They didn't really have meters in here. D is 311 meters. I just said 311. I didn't think there was actually, was there a meter symbol here? Yeah, they did. It was there. So that was in meters. The big thing is get the magnitude of what's going on and put in the meters later. We're fine. That's number 11. So number 12, for some reason I had managed to skip that. So let's just go to it. Very strange. Why would I do not have that anywhere, actually. Let's go. We have. Let's go number 12 right here. So that was number 11 that we just did. Let's do number 12. Let's do number 12 right here. Find D to the nearest degree when they're telling you this stuff. They've got something looking like this. This is not a good drawing, but let's say that's a 90-degree angle. This is 48.6 inches. This is 65.7. Find D. Well, I'll tell you what. I mean, we were kind of looking at it. Let me, maybe that makes it look a little bit better. There's 65. That's the hypotenuse. That's the adjacent. 48.6 feet divided by 65.7 feet. That is the cosine of D. That's the cosine of D. If you find the inverse cosine of this, and you find the inverse cosine of the cosine, you just get back to the angle. And that's going to equal D. And D is going to equal whatever's going to equal. I'm going to take 48.6, divide it by 65.7, and get the inverse cosine. 48.6. Let's see here. I'm going to go inverse cosine. 48.6. Inverse cosine, 48.6. Inverse cosine, 48.6 divided by 65.7. I'm getting 42.2919 and other stuff. They want this rounded to the nearest degree. So 42.29, 2.29 rounded to the nearest degree. Does that stay at 2 or go up to a 3? It's going to stay at 2. D is equal to 42 degrees. So there we go for that one. Let's just always be checking this, guys. I trust what they're saying. I don't always trust that I don't make a careless error. D is 42 degrees, so we're good. Let's look at 13. They're saying find J to the nearest whole number for number 13. Well, this is a very odd look to the whole thing to begin with. I'll tell you what. If this is 60 going all the way up here, and I want to find this, and this whole thing is 230, well, take 230 minus 60, take the whole 230 minus 60, you get 170 right here. This is a 41-degree angle, and this is the longest side called J. Going to do opposite over hypotenuse, 170 over J, opposite over hypotenuse is the sine of the angle. Multiply by J on each side. Multiply by J on each side. And then divide by sine 41 on each side. Divide by sine 41 on each side, and J is going to be this. Yeah, true. Absolutely true. Round to the nearest whole number, too, is what they're saying. So let's see where this goes to. 170 divided by the sine of 41 degrees. 170 divided by 259.123, roughly. .123. Well, is it going to stay a 9 or go up 1 to make that become 60, 260? That 1 doesn't do anything. So to the nearest whole number is 259, and that's going to be centimeters. I think they had centimeters to begin with. And we got that. Let's just make sure it's on the mark, guys. So make sure the calculator's behaving itself and everything else. This is number 13. J is 259 centimeters to the nearest whole number. 259 centimeters to the nearest whole number. You got it. So we're doing okay. That was 13. 14. Find out what's going on here. Well, find k to the nearest degree. If the roof diagram is an isosceles triangle. That's important. That's important. This side and this side are congruent to one another. They are also telling us that's 28 in height, 37 across. These are congruent to each other. A lot can be said. So there's a lot we have to say, I guess. Let's take the 28. You got to find the angle. So this is 28 in height, right here. It's isosceles, cuts it in half. So half of the 37 is 18.5 right here, and it's 18.5 right here for this right here, for that. That's 18.5. And so we got. Find k to the nearest. So it doesn't, either one's going to work, guys. The k happens to be here, but it's the same angle measure as it is over here. So either one you want. So here we go. You go right here too. That's 18.5, the whole thing. Well, I'll tell you what I'm going to do. Opposite over adjacent is tangent. The tangent of k is opposite over adjacent. The inverse tangent of whatever tangent you got is just going to be the angle from which it came. So inverse tangent of this is going to be what k is going to be. So let's take 28 divided by 18.5. $56.5466. 56.5466, round to the nearest degree. $54.5466 degrees. Make sure. Rather, I'm sorry, 56.54. 56.5466. Well, here's a 6. If it's 5 or more, if it's 5 or more, let's see what happens here. You're going to round up. So it's going to be k is equal to 57 degrees. So there it is for that one. Always make sure on these guys, 14, we said 57. 14, we said 57 degrees. We got it. So what do we got going on, guys? What else can we say here? Well, okay, I mean, it's looking pretty good. Find r for number 15. Find r to the nearest hundredth. So what do we got, guys? Find r to the nearest hundredth, huh? Well, let's figure out what's going on here, guys. If I go adjacent, there's a lot you can say here. I tell you what, how about opposite over adjacent, which is 2.18 over opposite over adjacent, opposite over adjacent is 2.18 divided by r. That's the tangent of 24 degrees. If you take the inverse tangent of this, you will have you'll have 24 degrees. Okay, that's great. It's an interesting question that can be asked, I guess you could say. We have got, well, yeah, what I just said is true. Perhaps this isn't the best way to solve for r. That second part wasn't, the second part that I just wrote down is mathematically correct, but not necessarily mathematically useful. This first entity is the way we're going to go. We don't need to complicate things, as I almost did complicate things. How it plays out, you guys. I would say that opposite of, here's the angle, 24 degrees. We know what it is. We know what that is. We don't know what that is. We know that opposite over adjacent is tangent. So 2.18 over r, opposite over adjacent is tangent of this angle. This divided by this is that's the tangent of 24. Multiplied by r on each side. There's a lot of ways to go here, but let's go slow, I guess. Now divide by tangent 24 on each side. And r is going to be 2.18 divided by the tangent of 24 degrees. It's a big move. We're not done, but that's a big move. This is where it's at. This is where you're going to get it. This is where it's going to work. Let's go for it and do any kind of round-offs we got to do here. R is going to be equal to 2.18 divided by the tangent of 24 degrees. .896. So let's see here. I got 4.896, so let's see how the whole thing plays out. Yeah, right. 0.896 to the nearest hundredth. Is that going to stay a 9 or go up to a 10? Well, if it goes up to a 10, which it will, it's going to be 4.90 inches. And that works. R is 4.90 inches. That was number 15. Absolutely. R is 4.90 inches. Let's go to 16. Find angle H. Find angle H to the nearest degree. Okay, sounds good to me. Here it is. Here's the angle. It's H. We know that opposite over hypotenuse is sine. The sine of H, the sine of H, the sine of H is opposite divided by hypotenuse. As we've been doing, H itself is going to be the inverse sine of 6,580 divided by 7,680. Have they both got 80s in there? Okay, very good. Yeah, they do. To the nearest degree they want it. Sounds good to me. Just 6,580 divided by 7,680. I got 58.9559, etc. Absolutely. Absolutely. 58.9559. 9559. Rounded to the nearest degree. It's pretty close to a whole degree right there, that's for sure. Does that 8 stay an 8 or go up to a 9? Take a look at what's going on here, guys. Absolutely. This guy is going to be 59 degrees. For number 16. Yeah, 59 degrees. There it is. Yeah, number 16 is going to be H equals 59 degrees. When you round it, you round that to the nearest degree. Okay, 17, 18, and 19. 17, 18, 19, and 20, especially 17. Pretty interesting conversation, I guess you can say, vis-a-vis how you actually do a problem like number 17. So let's take a little bit of time when we do it. Let's start with 17, then let's do 18, 19, and 20, and we'll kind of take it from there and see what kind of pace we can hit to get this thing done. So what we're talking about okay, guys, let's see what we can do. Catch some of these and see what we can say. 17 is very interesting. Find the area of the shaded part of the figure, round to tenths. Well, I guess there's an easy way and an easy way to do this, and neither one of them is not a little bit complicated, but not really difficult. They're saying if you got something like this, and you got it coming over like this, and you got this guy coming over like this, and you got this coming over like that, and this is 40 centimeters, so it's also 40 centimeters over here. If this is 50 centimeters, and again, this is not a good drawing, guys, but let's pretend I knew how to draw. This is 30 centimeters, this is 30 centimeters, this is 30 centimeters, and this is 30 centimeters. And that means, though I did not draw this very well, these two triangles right here, top and bottom, these two triangles are congruent. Why are they congruent? They have the same length sides associated with the fact that they're both isosceles triangles, same length sides. That doesn't make them congruent, but their base, 50 and 50. That's 50, that's 30, that's 30. That's 50, that's 30, that's 30. These are congruent. They don't look like it because I didn't draw it really well, but they are congruent. What holds for one is going to hold for the other. Okay, there are a number of ways you can do this. They want you to find the shaded portion. They want you to find this area that's in yellow, that I'm putting in yellow. They just shaded it. They didn't really put colors on it. All of this, including this. They want you to find that. Well, I got an idea. You could kind of cut it right here and make, you could cut it right here and find the area of this trapezoid. Cut it right here and find the area of this trapezoid. Find the area of this trapezoid. The area of this trapezoid plus the area of that trapezoid gives you the whole area. I got another way to do it. What do you say you take 40 by 50, length times width, and get 2,000 square centimeters, I'm sorry. Why don't you take the 50 by 40, go 50 times 40, get 2,000 square centimeters, and then subtract each triangle from it. Well, if the triangles are congruent, find the area of one of the triangles, double it, and subtract it from 40 times 50. That's the way I'm going to do it. The way you can do that is break it right there, and let's see how tall this thing is. I can figure it out. Well, if this thing's 50, this is 25, and that's 30. This is 25, and that's 30. I get it. Well, let's get this guy, H. The whole base is 50. The whole base is 50 up there too. But it's, you know, it's 25 right here, and it's H right here. It's a neat one. The rest is the Pythagorean theorem, in a sense. So let's see what we can say here. Tell you what, we'll call this guy A, call this guy B, we'll call this guy C, the big one. The big one right here is C, this one's A, and that's B. C squared equals A squared plus B squared. I don't know what B is, so I'm going to subtract A squared on each side. We said B is going to be the height. B is equal to H. Don't know what H is, so I don't know what H squared is. C, C right here is 30. A is 30 squared, 900. 25 squared, 625. Do the subtraction. There's no shortcut here. H squared equals 275. $16.583. Okay, keep it in mind. Tell you what I'm going to do. I'm going to take the height, 16.583, multiplied by the base, 50, and get, something on the order of 829.15. Absolutely, 829.15. Then I'm going to multiply that by a half, and I'm going to get 414 point, 514.575, something like that. Basically what we're doing is the whole area, you guys, total, let's just call it area, maybe it's easy out where we are. Get the area of the rectangle. The area of the rectangle is a length of 50 and a width of 40 minus 1/2 base times the height, 16.583. Well, we did whatever we did here, and I think I told you what I thought the answer would be on that. It'd be 800, the way I looked at it is there's kind of a trick to it, I guess. It'd be 1658.3. Half of that would be 829.15. Then half of 829.15 is about 415. It's about 415 subtracted from 2,000 is about 1,585, somewhere in that vicinity when we actually do it. So the total, well, let's see. I mean, there's a lot of places we can make a careless mistake here. This is going to be 2,000. This is going to be on the order of 415 or so. It's going to be 1,585. Ballpark answer. Let's see. A lot more than this on the calculator for this one. So the answer is this times, the height is 16.58 and some business, times 50 times 0.5 is that. Subtract that from 2,000, 1,585.422. Let me see what kind of answer they want here. Round to tens. Also, I'm not worried about it. Round to tens. 1,585.422. Round that to the nearest tenth. Does that 4 stay a 4 or go up to a 5? It's going to stay a 4. So the total, and there's other ways you could have done it. You could have done it a little more difficult, man. You could have been breaking stuff up left and right here, which would have been, man, a pretty good mess is what it would have been. I mean, you'd have found this thing right here being about 16.583, and this one being 16.583. Add them together, that's 33 let's have a look here. That's 33.166. How far short is that? 33.166. How far short of 40 is it? It's about 7 short. It's more like 6.834 short. So this is right here. This would be 6.834. This would be 40. So 6.834. This would be 40. Add them together, divide by 2, and multiply by this distance, which is 25. Do it again over here. It's the same thing. Just double it. You're going to get the exact same answer. You don't have to go there. You don't need to go there, guys. What we're doing at the end of what I just did is, of 2 options, neither of which is very easy. They're both somewhat easy but tedious, but neither one of them is very convenient. This is probably the better way to go on this. Did they have this? They got these in centimeters. So that'd be interesting. The mathematics, the argument is correct. Hopefully I did not make a careless mistake, which would make it wrong. My argument is valid. If you do it with this kind of an argument, your argument as well is going to be valid. Let's just see if it's okay. 1585.4 square centimeters. (17). Wow, we're not agreeing, man, so something's got to be off here. I don't know where they're I'm not sure where they're going with that. 2000. Wow, I'm not agreeing, but that doesn't mean I'm right. I'm going to say they're right because just about every time they're right. So let's have a look. They got 1170.8 as the final area. Wow, I like what I did. My argument is valid. Doesn't mean I'm not wrong, but I'm having a hard time buying it. What did I do wrong? Yeah. Okay, I know what I just did wrong. It's 2. I only subtracted one of the triangles from it, so yeah, I guess so. Yeah, I think okay. I think that's gonna be right. Tell you what. Here's what I did wrong. Minus this. That's one of the triangles. You multiply it by 2. And that'll do it. And that'll do it. It happens. It's going to happen, guys. It's better to catch it now than have to catch it later. Let's see what we got. Yeah, if this doesn't work, I think I got nothing. I'm going to have to go back and do the whole thing completely over. Let's see what we do have. Here goes. Let's try to do it exactly. Hardest part now is just redoing this part of it. Okay, so we got it. Everything's okay. I only took away one of the triangles. I found the area that would be present if you only got rid of one of the triangles. You're supposed to get rid of both of the triangles. If I got rid of one of the triangles, the answer I gave would have been valid. It would have been this triangle gone, this triangle present and included with this. That would have been your answer, the 1500 business. But I'm getting rid of both of these triangles. So I'm going to go let's find the area of the whole thing before you start subtracting things. The area of the whole thing, the area of the whole thing is 40 times 50. That's 2,000. Right here. The area of one of the triangles is 16.583. 16.583 times 50 times a half. It's 1/2 the 50 times 16.583. And you also do the exact same thing over here, and then put them together and take these two here, put them together, and subtract them from the total. The total that would have been, if nothing was being taken away from it, is 50 times 40 is 2,000. 1/2 50 times this gives you one of the triangles. You've got two triangles that I ignored at first, but now we're getting it. Let's see what we got. Notice the 2 and the half canceling. You're just doing that. Jackpot. 1170.843. Let's see what they wrote. They might have written something slightly off there. Now, what did they want for an answer? They did want to the nearest tenth, I thought. Round to the nearest tenth. Round to tenths. $17. I got 1170. I have 1170.8438. 0.84 rounds to 0.8. So it's 1170.8. And that is it. The logic was largely right, but not completely. I just took away one of these triangles. I'm supposed to take away both of them. And that does it. That will do it. And that'll get you that. They're right again. They're batting 1,000. Which is good to see, which is great to see, actually. That was 17. Using sides x, y, and z in right triangle x, y, z, define sine x, cosine z, tan x. Okay, what are they talking about? Well, they're given 18, 19, 20. Small y, small x, small z, we got this. Okay. Using everything you got there, guys, give me the sine of big X. The sine of big X is opposite over hypotenuse. This is the hypotenuse. That's the hypotenuse, guys. It's opposite the 90-degree angle. Sine of big X is opposite over hypotenuse. Is opposite hypotenuse. Cosine of z is adjacent over hypotenuse. Tan of x is the rise over the run, or opposite over adjacent. Tan of x is opposite over adjacent. And there we go. Okay, guys, 18, 19, and 20. Just make sure, always check. Why not check if they're giving it to us? 18, 19, and 20, x over y, 18, 19, and 20, x over y, x over y, x over z. You got it. Sounds good. Let's go 21 through 28. Let me clear this and have this thing set up so we can knock it out. Hello, everyone. Let's just keep going. Well, I mean, there's a lot of things going on, guys. There's the law of sines, there's the law of cosines, and that's going to help us with a number of the problems that we're going to encounter. The law of sines is basically saying for any triangle present, any size and shape, so to speak, it doesn't have to be a right triangle or anything. If this is angle A right here, if this is angle A and this is A, if this is angle big B and this is B, and this is angle big C and this is C, the sine of big C over small c equals the sine of big B over small b equals the sine of big A over small a. Additionally, if you wanted to find, let's say, A, for example, A squared, or C, for example, maybe make it look a little bit like the Pythagorean theorem. It's proved using the Pythagorean theorem. C squared equals A squared plus B squared, even if it's not a right triangle, as long as you go minus 2AB. What's opposite the C? Big C, right? 2AB cosine big C. That's the law. This is the law of cosines. Law of cosines, laws of sines. And that's going to help us figure out what we're doing. Having said that, find the area, find the length of z. I guess there's a lot to ask. Let's find the length of z first. The length of z, and we can do this, like I said, a number of ways. It doesn't matter. Now, all these work. If you get the reciprocal of each one of these, the reciprocal is going to be equal. How you might want to look at this, I mean, you could say that z over the sine of 120 degrees, z over the sine of 120 degrees is equal to 20 over the sine of 47 degrees. Well, if you multiply by the sine of 120 degrees on each side, z is going to equal 20 over the sine of 47 degrees times the sine of 120 degrees. Well, there's a lot there. Let's find out what it is. Using this, find the length. They didn't really specify how they want to do some of this, so let's do it. What we have here is 20 divided by the sine of 47 degrees. Get an answer, then multiply it by the sine of 120 degrees. I'm getting 23.6828.
let's have a look. 23.6828 rounds to 23.7. They didn't specify where they wanted to round off, but 23.6828 rounds to 23.7 if you go to the nearest tenth. They didn't really specify that, but the answer that they gave is what they gave. So, sounds good to me. As far as area, you got to get the base and the height. So I'll tell you what, the 23.6828 is what that is right there. So call it 23.7. On my calculator, I might keep it pretty rigorously a little more than that, a little more decimal places. I have 23.6828. Maybe when I'm dealing with this. But I got this. The area is, I guess you could do a whole bunch of things here on this one. You could do a lot. I mean, you can answer more questions than you probably need to answer as well. I mean, you got 120 degrees right here. Everything's got to add up to 180. This is 120 degrees. Add 47. That's 167 degrees. That's 13 degrees short of 180. That's 13 degrees. Is that good to know? Yeah, arguably it is. Because what happens is, if I want to find this vertical height, h, then I'll use the base which is 20, times the height, which is h, and I'll get the area. The area is going to be 1/2 the base times the height. The area is going to be 1/2 the base, which is 20, times the height. The height is interesting. The height is h over z is the sine of 13 degrees. H over z, so I guess I'm going to run out of room, guys, what's going to happen here. H over z, h divided by z is the sine of 13 degrees. Multiply by z on each side, z sine 13 degrees is going to give you the height. Well, we just said that z was 23.7, 23.6828. Multiply that, that's z. Multiply that with the sine of 13. The height becomes 5.327. The height is 5.327. That's good because that's what I'll put right here. 5.327. So we're going to do the height, which is 5.327, times 20, times 1/2, 53.2747. So what we have here is 53.2747. Okay, nowhere do they have centimeters here, man, but they got centimeters for an answer. Okay, that's okay. 53.2747 rounds off to 53.3. And yeah, absolutely. Absolutely true. So we ended up getting what we're getting, guys. The way this played out was, like I said, you got this here. I don't know. I don't like erasing too much of anything, to be honest with you. But we solved a lot of stuff here, guys. We know what we're doing. Let's just to kind of recap so you can see what we actually did. like we said, this was whatever it was. I mean, how we played the game with this thing, man. It was 23.7 centimeters. To get the height, we went h over z was the sine of 13 degrees. Multiplied by z on each side, you got this, and that's where you got the 5 point something that was going on here. 5.3, again, the 23, yeah, it was 5.327, etc. So this guy's 5.327, something of that nature. Just see where the round-offs are going here, guys. 5.327 and the 4 and the whatever. It's good enough. Once you got this, and once you got this, you multiply this with this, and then multiply by a half. Again, the area is going to be 1/2 the base times the height, which is 5.327, which is 53.27, whatever it's going to be. So this was the 5.327 here, centimeters for the height. Okay, this is how you got it. And at the end of the day, the round off here when they actually did it was 53.3 centimeters squared. Okay. Again, this stuff's usually easier done than explained. If you got a little more room, you kind of go at your own leisure with that. But I think we see where I'm trying to go with that, guys. So when you're looking at this, try to find what's what, I guess you could say. There's a lot that you can say here, guys, I guess, when you want to do something. They want you to find y. They want you to find angle y. They want you to find angle z. And there's a lot here. There's a lot here, and I put a lot here. Okay, there's a good amount there anyway, so that's good to see. This game can be played a lot of ways, I guess you could say. We could maybe figure out what we're doing here. I'd probably do this. To get all the angles, you could just say this. Look, from law of sine, 5 over 12, or 12 over the sine of 35. You can go either way. Just make sure they match up. Go sine over length equals sine over length, or go length over sine equals length over sine. That's not a big deal. 12 over 12 over the sine of 35 degrees, 12 over the sine of 35 degrees is equal to 15 over the sine of z. Okay, pretty neat. Let's multiply by sine of z on each side. Let's multiply by sine of z on each side, and then multiply by sine 35 degrees over 12 on each side to cancel that out of there and go over here. Make a long story short, make all the manipulations that you need to make. So you got multiply by sine z on each side. You got to here, 12 sine 35 degrees. Multiply by sine of z on each side times this equals 15. Multiply by the reciprocal of this on each side. You got sine of z, big Z. Sine of big Z equals 15 times sine 35 degrees over 12. Yeah, it's a little bit of a mess. Sine of z is going to be this mess. Get the sine
let's see here. We'll get the sine of 35. We'll get the sine of 35 degrees, divide it by 12, and then multiply by 15. 0.71697
get the inverse sine of 0.7169, get the inverse sine of that. $45.8 degrees is what I got there. Sounds good. So for B, 45.8 degrees, they got 46. They're rounding off to the nearest whole number. They didn't really specify, so we're not going to worry about it a whole lot. They really rounded off. They rounded the nearest whole number. I got 45.804926. The 45.80, they rounded it off to 46. So they're saying 46. 45.80 is what I'm getting. Which is approximately 46 degrees. Sounds good. I mean, just kind of, I'm not sure we even need to go to that level of specificity, but this is just so you know how they're getting that answer. They're getting it right here. That's 46 degrees about. Okay. Well, if that's 40, if the z is 46 degrees, what's 46 degrees and 35 degrees? It's 81 degrees. How far short is 81 from 180? That's 99 degrees. I don't even know if they went there. They did. So C is 99 degrees according to them. If you're going to make the conclusion that 46 degrees is what you're looking at, then the y is going to be 99. Because 99, 35 and 46 is 81. 81 is 99 short of the whole 180. So we got this. So we're doing good there. From there, you can keep playing laws of sines to get a lot of what's going on here, guys. These do take a while, a little bit, but we can do it. So we got guys. We got the angles we got. I mean, as I said, we said it was going to be whatever it was going to be. I mean, Z was 46. We talked about all that. Let's get what Y is. Well, Y is, law of sines, Y over the sine of 99 is going to be equal to 12 over the sine of 35. I can do this a number of ways. Y over the sine of 99 degrees is equal to 12 over the sine of 35 degrees. Laws of sines applied as you wish to apply them. This is the y right here. y over the sine of 99 degrees is the same as 12 over the sine of 35 degrees. These are very provable entities. We're not going there. If we have a chance ever, why not prove them? But y is what it is, multiplied by sine 99 degrees on each side. See where this is going to go. Sine 99 degrees over sine 35 degrees. Sine 99 degrees divided by the sine 35 degrees. At the end of the day, multiply by 12. I got 20.6638. 20.6638, they got 21. .6638, that's approximately equal to 21. Forgive me, that's just length. Did they write centimeters on that? I don't think they did. Okay, it doesn't matter. It's not, they're not really specified. The big thing is the 21 there. That's fine. That works. .21 is what they're rounding it to. Obviously, in all these instances, you guys, from everything that I can see in all these instances, there's 12, there's a 15. We're rounding the 20.66. We're rounding the 20.6638 to 21. We got 21, we got 12, we got 15, we got 35, we got 46, we got 99. I guess the handwriting's on the wall. We are rounding everything to the nearest whole number. So that thing becomes, as we do it, it's approximately equal to 21. It's really the 20.66, the 20.6638, but the 21 is fine, and that is what we're getting. So we got this. It's looking okay, guys. That's everything going on over there. So we said some stuff. We're going to be using law of cosines or law of sines. Law of cosines and law of sines are useful. We'll be using them at some point or another. And we can talk about it. Well, guys, okay. I mean, there's a lot here that we have said. Let's keep talking. All right, we'll use this for 23 if we need it. We'll see what we can say. Number 23, that drawing I have up there that looks kind of weird. It looks like looks like a forest or a garden. It's supposed to be a lake. From one end of the lake to the other, from one end of the lake to the other is the whole distance. To cross the lake. So from A to C is the distance across the lake. There's the lake. So what is that straight line, A to C? What is that distance? Well, they've used different things here. I think they were supposed to be talking about, this is supposed to be kilometers actually. They've got it written as meters, but it's supposed to be kilometers. Not much of a lake if it's meters, but who am I to be speaking, guys? I make countless mistakes when I do this stuff, as we've already seen. Let's take a look at this. How are you going to do it? Probably the easiest way to do this thing is say that distance all the way across Distance all the way across, we'll call it b. So, I don't know, I would say b over the sine of, and this is all provable, guys. It's not particularly difficult to prove either, but it is a little on the tedious side. But we can prove the law of sines. It's not our business right now, though. B over the sine of 70 degrees is the same as 2.4 over the sine of 30 degrees. That's it. Law of sines. And you can write law of sines in different ways. You can put sine on top, you can put the sines on top and distances on the bottom, or distances on top and sines on the bottom. Not really a big deal. Generally not a big deal. So let's have a look. I don't know what b is. I'm going to find what the sine of 70 degrees is and move from there. Tell you what I'm going to do. I'm just going to, let's just kind of cut to the chase. Maybe there's an easier way to do this. Multiply by sine 70 degrees on each side. And you got 2.4 times the sine of 70 degrees. Well, there's some easy stuff you can do. Relatively easy, makes it maybe a little bit easier if you catch it. The sine of 30 degrees is kind of a famous quantity. The sine of 30 degrees is 0.5. 2.4 divided by 0.5. The sine of 30 degrees is 0.5. 2.4 divided by 0.5 is 4.8. Multiply it out. Do it any way you want. Go a little more, take a little more time to do it if you want. Find this, take this, divide it by this. You're going to see it's 4.8. Then multiply by the sine of 70 degrees. Well, as we see, guys, we got 4.8 times the sine of 70 degrees as the shortcut I've shown you. 4.8 times the sine of 70 degrees. I got 4.5105. So 4.511. Let's see where they're going. 4.511, they just got 4.5. Okay, good sized lake. B equals 4.5 kilometers. Across the lake is 4.5105, something like that. Let's see what it's got. Absolutely. It's got 4.5105. 4.5105, about 4.51, which is about 4.5, which is fine. That's number 23 regarding that. Let's do the last 5 of these for this particular sheet, and we can take it from there. And I might want to just talk about something else briefly before we conclude this particular discussion after I do the last 5. So 24, 25, 26, and then 27 and 28. Let's see what we can say about it. Let's get to that. I'll have them on the board very shortly for you. All right, hello everyone again. Let's keep going. For number 24, they're saying a large tree was partially blown down in a windstorm. To keep the tree from falling further, an 18-meter cable was attached to the tree, attached to the tree 12 meters from the base, and to a stake in the ground. The cable makes a 40-degree angle with the ground. How far is the stake from the base of the tree? I'll tell you guys that the last couple times I read this, it didn't always make complete sense, but the drawing does make sense. The there was an 18-meter cable attached. So an 18-meter cable was attached to the tree 12 meters from the base. The 12 meters is at an angle in its own right, so it's a little confusing to me, but the drawing is not confusing, which is the best thing. So essentially they're asking here, how far is the stake from the base of the tree? Hint, figure this out. The stake is right here, you guys. That's the stake they're talking about. So how far is it from the base of the tree? Now, we're assuming the tree itself, a better drawing would be the tree comes out to here, so we'll call that the base right here. So they want to know how far is that distance? Let's call it x. That's the big thing they want to know, you guys. They want to know how far is that distance. Let's find out that right there that's in green. Well, that shouldn't be too bad, but you know there's a number of things that do go on, so let's be careful with it. You can say 40 degrees and 12 correspond to each other, and this angular measurement and this correspond to each other. Let's call this, let's call this big C. So this is the big C right here. So what they're asking here is, basically what we have, guys, and let me see how much, hopefully I don't know how much room I'm going to have here. I'm not always putting this in the right way, but let's see what we have here. What we have is, by the law of sines, the sine of C over 18, the sine of C over 18, the sine of C over 18 is equal to the sine of 40 degrees over 12. Okay, so that's pretty interesting. Don't know how good, the camera's showing all this stuff all the time, guys. Let's see what we can do. So basically what we're talking about is the sine of C over 18 equals the sine of 40 over 12. Let's find what the sine of C is. Let's multiply by 18 on each side. Sine of C is 18 times sine of 40 degrees over 12. The sine of C is going to be equal to all this when you get it, and let's see what that comes out to. Well, 12 let's see here. 12 goes into 18 1.5 times the sine of 40 degrees. The sine of C is going to be 0.96418 0.96418, and then other mumbo jumbo, I guess. So if that's that, get the inverse sine of that. 74.618, 74.619, that's C. It depends to what degree of accuracy you're trying to play this thing, you guys. I'm kind of apprehensive to round off too much at the end of the day on this thing. Now, it's kind of interesting how they wrote this. That in itself is kind of an interesting thing as far as C is concerned. This thing, you know, it's a fascinating point in its own right. This is a obtuse angle. It's not an acute angle. It's bigger than 90 degrees. So the sine of 74.619 is indeed equal to 0.96418. Yeah, 180, the supplement of that, 180 minus 74.619 is also going to satisfy that. And that's going to be the right angle. It's going to come out to 105.381. They just rounded it to 105, I believe. Let's take a look here. Yeah, they got it to 105. Let's call it 105. That's you got to really watch out for that. Both of these are true. Both of these are true, but this is not bent inward, nor is it perpendicular. It's beyond perpendicular. It's going to be more than 74.613. The supplement of this angle is 180 minus 74.619, and that gives you that. Man, that's not an obvious scenario. I guess here you're kind of going to look at the figure. Normally they don't tell you to just look at the figure as a guide. In this case, I guess you would. So 105.381, let's just call it 105. If this is 105 and this is 40, if this is 105 and this is 40, it's 145. This right here is 35. I don't know that we need to know that, but it's good to know that. 35 and 40 is 75, plus 105 is 180. The 105 is the big one. Let's talk about it. I mean, there's a number of things you can say on this one. Depends how rigorous you want to get with it as well. That would be the acute angle that has it, and that would be there's the obtuse angle and the acute angle. The sine of any degree measure between 0 and 180 degrees has potentially, the sine value comes from two different angles, unless it's a 90-degree angle. What's the 90-degree angle? The sine of a 90-degree angle is 1. The sine of an angle less than 90 degrees and the sine of an angle greater than 90 degrees can theoretically be the same value. They always match up that way. If we were to graph the sine function, it looks like this. It's called a sine wave. Here's 0, here's 180, here's 90 degrees for the sine. Notice you get at less than 90 degrees or at more than 90 degrees, you get the same answer. And you get that in an infinite number of places, actually. All supplementary angles have equal sine values for our purposes. As long as we're talking about angles that are between, for sure, as long as we're, there's other, devil's always in the detail. We can expand this thing in both directions, and we can talk about conclusions. Right now, let's talk about triangles. 180 degrees in a triangle. The biggest angle any triangle is going to have in it is something a little bit less than 180 degrees. Let's talk about 0 to 180 degrees when we talk about supplementary angles having equal sine values. If this is 70, and this is 10 away, forgive me, this is 20 away rather. If this is 70, 20 away from 90, 70 is 20 away from 90. Well, 20 away from 90 on the other side is 110. If you get the sine of 110 and the sine of 70, they are equal. So that's where that's coming from. Just kind of watch out. Yeah, they're saying a number of things here. I don't know how far we want to go with this, to be honest with you. Let's do the law of sines again and see what we can do about it.
All right, guys. So if that's 105, I don't know. Are they staying with 105, or are they going with the more accurate version of it, which is, which is going to be 105.381? You got me. Let's see what they did. It could make a difference is how they're reporting this. I'm not going to nickel and dime something like that when you're doing it. We're going to figure that out. I mean, if it's clear you know what you're doing on that and your procedures are 100% right, that should be fine. We should be all right. So what we can say here is, guys, we can say a lot, obviously, and we do say a lot. So you got any other conclusions to make? Well, yeah, I think we do at this point. If we know that's 35, it is very useful, actually. We don't know what x is, but we do know that x over the sine of what we know that angle to be, 35 degrees, x over the sine of 35 degrees, x over the sine of 35 degrees is the same as 12 over the sine of 40 degrees. This way I don't have to worry about the round off. I'm going back to the 40 degrees. Go here too. I could go 18 over the sine of 105, or 18 over the sine of 105.381. Okay? I almost want to go 105.381. I tell you what, to get out of it, I'm not even going to work with it. Here it is. I know what it is. I know what the angle is. I gave what the angle was, and we know that. We know that angle C is 105 degrees, according to this. And we're about to find out what this is. Well, here goes. Find out what it is. I know what x was. X over the sine of 35 degrees is the same as 12 over the sine of 40 degrees. Let me do the algebra, and we're all set. Guys, let me just make sure my microphone's working too, make sure I'm completely set. All right, guys, so what we have here is sine 35 degrees times 12 divided by the sine of 40. Sine 35 degrees times 12 divided by I got 10.7079, 10.708. Have a look. Yeah, 10.708. They got meters here. I don't know if there were, there were meters there too. Yeah, they rounded to the nearest whole number. They got this thing at 11 meters. So x is 11 meters. When they round off, they go pretty strong with the round off. That's okay if you're warned about it. If you know what to ask for, at least, or if you're not really specifying, people are reasonable with what they are encountering regarding something like this. So that's that. That's that. 11 meters, 105 degrees. Got it. Everything's there. That's 24. Let's look at 25. 25, there's a number of ways to do this as well. I am going to have to take another look at it because at first glance it's a little more, I think it's a little more confusing than it deserves to be.
viewed as. Let's see it. Okay, that would explain what is going on. For some reason, I didn't write the angle on it, because otherwise I was wondering, I'm not sure how we're going to do this, to be honest with you, if they're talking about something like this. I don't know that we could. We'd have to have an angle on there as well. They want us to find side C right here. They are telling us something that I did not initially write down, but we got this. So that's going to get us there. What you're going to do is the law of cosines on this one. You're going to say C squared. You know, you can call this guy A. You can call this guy B, and you can call this the angle C. You can call it the angle theta. But this angle is sandwiched between these two legs, and you're trying to find C. C squared equals A squared plus B squared minus 2AB cosine theta. In this case, the theta is this. So we got this, and looking something like that. That's about it. Grind this out. Let's see what's going on here. C squared equals A squared, which is 13 squared, B squared, which is 7 squared, minus 2AB. A is 13, B is 7. A is 13, B is 7. Cosine 47 degrees. Going over a little bit, guys, once again, but absolutely. So what do we got here? What we got here is C squared equals 169 plus 49. 2 times 13 times 7, well, what's going on with that? 7 times 13 is 91. You double it, you get 182 times the cosine of 47 degrees. It's the hardest move you're going to make on this whole thing. C squared is going to be, I'm going to add 149. Forgive me. I'm going to add 169 and 49, and that's simply going to be 2 less than 220. It's going to be 218. When you look at it, let's have a look at it. I think it's about 170, about 50. Yeah, 220 about it's going to be 218. 218 minus this. Get whatever you're going to get there, guys. C is that. Let's see what we got here, guys. I got 9.66, forgive me, I got 9.6889, 9.689, let's say. Let's see where they're going with that. Yeah, right. 9 point, 9.689. 9.689, right. So, yeah, 9.689, they went and made that 9.7. 9.689, they rounded it to the nearest tenth, that's 9.7. .7. So there you go. Same kind of argument here on in with this stuff, you guys. It's essentially the same kind of argument. Here they just want you to find, they're telling you a number of things. I just want to make sure I got everything I need here. Yeah, there's an 11 right here. There's an 11 associated with him. There's an 8 associated right here, and there's a 14. All right, sounds good to me. What are they asking for? Well, they're asking in this case, find angle X. Find angle X. That's a good good question, I guess you could say. Could do it a bunch of ways. We don't. Do a whole bunch of things. I mean, probably the easiest. Well, I'm not sure I can say that it's easy, but maybe it's about the easiest thing you can do in a relatively challenging scenario that they have set up for us here. You can take this guy, which is angle X, and they want you to find. They want you to find angle X. They want you to find angle X. Okay, good luck. I tell you what, if you're going to find angle X, let's have this guy, let's call him C. Let's call this one A. Let's call this one B. And let's use the law of sines. Forgive me, let's use the law of cosines. We know that C squared equals A squared plus B squared minus 2AB cosine theta, whatever the theta may happen to be. In this case, the theta happens to be X. So we know a good amount. This is a little bit of a high wire act, guys. At that point, you look at it, you got to look to get, there it is, cosine X. Well, yeah, it's the one I want to find, actually. Well, let's do as much math as we can. We're going to call C 11. C is 11. We'll square it. A is 8. We'll square it. B is 14. We'll square it. Minus 2AB cosine X. That's the big mystery. The cosine X is what you got to somehow isolate. It's not a big ask. It just takes a little bit of time. Need a little bit more room. At this point, I'm probably going to erase a few things, guys, to get everything in here. So we know a lot. To have the room, I guess. So we got a lot. We're looking at a lot. Here we go. We continue to look. 11 squared is 121. 8 squared is 64. 14 squared is going to come out to 196. Minus, don't worry about, yeah, 14 is bigger than 11. Don't worry. The math is going to come out. There's ways you can prove all of this. For right now, just trust me, it's true. Even if there's a 14 right here that's bigger than the 11, do the law of cosines and you're going to be fine. What we have here is you're going to minus this product, and the product is 2 times 8 is 16, 16 times 14. It's an interesting matter in its own right, I guess you could say. That should be 224. There's a trick to it. The big thing is, we got this guy right here that's got to be dealt with, and we're going to deal with him. We're going to deal with him. But we got all that. Tell you what I'm going to do. I'm going to add a positive 224 cosine x on each side and subtract 121 on each side. (224 cosine x), add a positive 224 cosine x on each side and subtract 121 on each side. And it's going to be 64 plus 196 minus 121. Well, okay. See how that all plays out. 196 minus 121 is going to be 75. 196 minus 121. 196 minus 121 is going to be 75. 75 and 64 is 139. Yeah, I mean, it's a bit of a mess, but it should come out to that okay. As we said, we subtract these two and got 75 as the sum total. Go over here. Yeah, it looks about right. Divide 224 on each side. Cosine of big X is going to be this, and that's not looking too bad. Get the inverse cosine of both sides. Get the inverse cosine of 139 over 24. Like I said, it's not necessarily an easy way to look at it. It's about the only way you can do it. It's not real difficult, but as you can see, it's a little on the tedious side. So we're going to do inverse cosine of 139 over 224. $51.6447. 51.64. Let's have a look. 51.64, they got 52. I'll let you guys know to what degree of specificity you can get away with, depending on what system's being used, what exam's given, what class you're in. 51.64 to the nearest to the nearest whole angular measurement, to the nearest degree. There it is. Wow, it takes a little bit out of you. It's not, you'll have an easier time doing it when you're doing it in pencil and paper than you're going to have running across, 30 feet of a classroom to do it. There's two different challenges in regard to that. So, but I think you're going to be fine. I mean, I think we're all fine doing this stuff. Again, X is 51.64 or thereabouts. They're rounding it to the nearest degree, so it's 52 degrees, and that's good enough for me. 27 and 28. 27 and 28. Find side X when they give you everything. Find this guy. Well, that's again going to be the law of cosines to knock this thing out. Okay? So let's
Let's talk a bit about it. Well, I just erased the law of cosines only to write it down again, right? That's all right. But we're going to use the law of cosines on this. Going to use the law of cosines on this. So what we're looking at for this one, typically the way it is, some c squared, some a squared, b squared minus 2ab cosine some kind of theta, some kind of angular measurement that's there. In this case, the angular measurement is the angle big X, which is 130 degrees. The big X is going to be the theta under consideration. We'll call this guy A, call this guy B. Doesn't matter which one you call A or B. Call the longest side, or at least the side under consideration. Probably calling it C is a real good move. So C is equal to X, and X is what you're trying to find. C is equal to X, so C is equal to X, so C squared is going to be X squared. The A is 15. The A is 15, the B is 5. Let's say it again. The A is 15, the B is 5. Cosine of theta is cosine of big X. It's cosine of 130 degrees rather. And we got all this. A little bit of a mess, but it shouldn't be too bad. What do we got? We got 225. We got 25. We got this times these two multiplied together, right? You can do this a whole bunch of ways. Here's a minus. We took care of the minus. 2 times 15 is 30. 30 times 5 is 150. Times cosine, 130 degrees. Well, it's a little bit of a long song and dance. But, I mean, at this point, this is 250. This is 150 cosine 130 degrees. Like I said, guys, sometimes it's easier done than actually said, but you got to be careful. You've seen me make my share of mistakes trying to do these. It's relatively easy stuff, but it's not that easy. And like I said, you got to watch it. You got to know what you're doing here. Well, I don't know. You have to do this whole song and dance underneath the radical, get an answer for what's underneath the radical, then get the square root. Get whatever's underneath the radical, get the answer for whatever's underneath the radical, then square root it. And if you square root x squared, that's equal to x. If you square root both sides, make a long story short, you're going to find what x is. So the way this plays is, $250 minus 150 cosine 130 degrees. 250 minus 150 cosine 346.418. Get the square root of that. 18.6123. 18.6123. They're rounding it to the nearest tenth. Did they say that? It's hard to keep track here. They didn't really say it one way or the other. So, I mean, there's a lot of flexibility, guys. I'll let you know how I want you to report something. In the meantime, just get it right. Here's a 6. Go right next to it. There's a 1. Does that 6 round up to a 7? No, it's not. No, it's not going to happen. And you got this. Know this stuff, guys. Know how to do it. Know how to do it. That's 27 all day. Okay? Stuff's not too bad. It's not too bad, guys. I mean, the way they're asking, 28's asking a whole bunch of questions, I guess. We'll cross each bridge as we need to cross it. For right now, We got what we got for number 27. We got what we got for number 27, guys, so it's looking pretty good. Let's do 28. Let's give ourselves some room to do it. So let me get rid of this. And that'll be it with that. I just wanted to kind of maybe make a note on one thing that we did earlier. You'll see it in the film, and in the end we caught it, we corrected it, but maybe just to kind of just emphasize a few things. All right, that's 28, so let's go with 28. They're asking a bunch of questions with it, so let's answer them. They're saying, how far is A from P? Well, my fault. I didn't really draw the letters, guys. Here's A. Here's B. And here's P. And there's P. A, B, P. So let me see if I can write that. I don't know if I'm going to write any better, guys. It's not going to look any better. There's P. All right, A, B, P. Let's see what they're asking there. How far is A from P? This distance right here, let's call that X. How far is A from P? Call it X. How far is A from P? How far is B? So how far is A from P? How far is B from P? We'll call that Y. That's B from P. What is the width of the river? We'll call it W for width or height or whatever you want to call it. What the heck? We'll call it W for width. We want to find the distance from A to P, we'll call that X. The distance from B to P, we'll call that Y. And the perpendicular distance to this bank of the river from this point up here, that perpendicular distance going straight down where it's a 90-degree angle with the river here and a 90-degree angle with the river there. All these 90-degree angles, it's kind of implied to be that way. That's W. So we want X, we want X, we want W, we want Y. Fair enough to me. What do you think? Well, there's a lot to think about. Here's one thing to think about. If this is 55 degrees and this is 45 degrees, if you add 45 degrees and 55 degrees together and 45 degrees together, you get 100 degrees. 100 degrees plus, even here, guys, let me see here. Let me kind of write this so there's room to see it. If this is 55 degrees and that's 45 degrees, that's 100 degrees. This right here has got to be 80 degrees. I hope that's visible. It's kind of, there we go. That's 80 degrees. That's 55 degrees. That's 45 degrees. Hopefully that makes it a little easier to look at. Okay. 45 degrees, 55 degrees, 80 degrees. 45 degrees, 55 degrees, 80 degrees. Sounds good to me. Law of sines all over the place on this one, and we should be pretty good. Y over the sine of 55 degrees this thing right here, guys, I mean, I've written so many things on here, it's hard to know what's what. That length right there, right? And then there's a length right here. There's a length right here. There's the length right there. All right. I think it makes a little more sense. The whole length here, y, over the sine of 55 degrees, is the same as 60 feet over the sine of 80 degrees. So the length y, which I don't know what it is, divided by the sine of 55 degrees is this, and the length 60 divided by the sine of 80 degrees. I don't know what y is, but the length y over the sine of 55 degrees equals the length 60 over the sine of 80 degrees. That's all it is. Rest is a little bit of math. Sine 55 degrees sine 55 degrees over sine 80 degrees times 60. Sine, again, let's say it again. Sine 55 degrees divided by the sine of 80 degrees. Get an answer, then multiply it by 60. All right, let's try this again, guys. This calculator doesn't always want to behave itself. Let's see what we can do. Sine of 55 divided by 49.907, 49.91. Let's see where they went. How far is A from P? Well, I actually solved this one. I actually solved for Y. And we said the answer was 49.91 or 40, something like that. Let's see what it was. 49.91 roughly. 49.91 for the Y. For the Y. That's B to P. That's B to P. That's part B then. 49.91 for B. Yeah, I mean they're rounding like it's pretty good here. 49.91, they're rounding it to the nearest whole number. Does 9 bump this thing up one? It sure does. You've got y equals 49.91. They're saying 50. 49.91 to the nearest whole number is 50. That's B. That's from That's 50. And that's this guy. According to them, it's 50. I mean, it's after the round off and stuff like that. Fine by me. How far is B from P? P is right here. That's P. B to P is 49.91. To the nearest whole number, it's 50. 49.91 goes to 50. How far is B from P? Okay, they're saying go 50. How far is A from P? That's going to be the X guy. X is going to be, the way you're going to look at that one is X. X is opposite the 45-degree angle. And there's a whole bunch of ways you can look at that, actually. X over the sine of 45 is equal to y over the sine of 55. They told us y is 50. I'll be honest with you, I don't know if I want to work with that. I'm going to go 49.91 just to play it safe. You could use 50, and it's probably not going to be a problem. But man, let me look at this. Let me take a look at this.
Multiply by sine 45 degrees on each side. 49.91 over sine of 55 degrees. And here we go. I mean, I don't know. Maybe this is a good move. Maybe it isn't. I don't know. Let's go with it. Times sine 45 divided by sine 55. I got 43.08. Yeah, that's about 43. I got a feeling that's where they're going. I got a feeling that's where they're going to stay. So A, the x is going to be 43, is what my instinct is saying. I used a more precise number than 50, even though they gave 50 as the final answer on that. They got 43. I think they were they even writing down feet from the get-go on this thing? Yeah, they were writing down feet. So these are all feet. They got 43 feet on this one. Yeah, it's okay. It's working good. You got to watch it. I think stay precise until the end and make the round-offs. That's kind of the modus operandi and stuff. I tell other students in other classes, in other places, stay with everything that's on the calculator until the very end and then make a round-off if you're going to make the round-off. That's usually not a bad move to make. They are asking, how high is this thing straight up? Well, on that one, I'll tell you what, I'm more confident, rather than 50, the 49.91. The x, the 43, is pretty damn close when we had actually done it, guys. Let's work with this one. If this one's 43, isn't the sine of 55 degrees w over 43? Opposite over hypotenuse. This becomes the hypotenuse if I make these two right triangles. Opposite over hypotenuse is the sine of this angle. The side opposite this angle divided by the hypotenuse is the sine of this angle. In plain English, the sine of 55 degrees is w over 43. The sine of 55 degrees is opposite over hypotenuse, which is w over 43. Multiply by 43 on each side. (43) times the sine of 55 degrees. Okay, there's other stuff. There's 43.08. Since I have it on the calculator, I'm going to leave it there. Times the sine of 55 degrees. I got 35.289, which is about 35.289 is about 35.3. Let's see where they are. They just got, for 35.3, they stayed with 35, which is fine by me. And that's for 28. And this comes, like I said, comes out about 35.3. They rounded it to just 35. Right.
Okay. So that's that. That gets us through the sixth. That gets us through the sixth of the 8 review tests. They're a little bit on the lengthy side, I guess. But once you know them, you basically know the course. You know the lion's share of the course, and it puts you know the lion's share of the course for Tech Math 1, and that's good for Tech Math 1 for the lion's share of the course. You just know most of what's going on there. You should be okay to get through it. For those in another course looking at this, at least it gives you a lot of basic knowledge on how to attack certain problems and get answers and hopefully not make careless mistakes. We all make them sometimes. Let me try to go back. I already corrected this kind of live when we were doing it. Let's just kind of look at it one more time. Let's just go back. I mean, we're through all 28 of the problems right now, and I hope everybody's feeling pretty good about it. If we look at what was going on with problem 17, let me just quickly, at least try to give you 2 looks at it and make sure we're straight with where the answers got to go, where the arguments are. Now, again, unfortunately, I didn't write down the exact numbers, so I guess I'm going to be getting on the calculator again. But let's see where this goes. Good stuff to know. Really good stuff to know. It helps you in physics when you're talking about vectors, when you're talking about trigonometry, and those 2 topics occur very much in physics. Vectors and trigonometry and how they relate to one another and distances, adding up different components of what's going on. Very important stuff. Back to 17, just hopefully briefly. I don't want to, completely beat this thing up. But as we had this thing set up like this, it's an easy problem if you're talking about a 50 centimeter length all the way across like this, which is what you are talking about, and a 40 centimeter length, which is this. Well, 40 times 50 is 2,000. 2,000 square centimeters. That's the area of that whole thing. Well, they tried to pull a fast one on us a little bit. They did something like this. And let me try to make it about right. Something like that. Something like that. Now these, let's assume these are, man, this is not looking too good, but all right, let's go here. These are 2 isosceles triangles. How do I know that? Because this is 30 centimeters right here. This is 30 centimeters right here. The 2 legs are equal. It's an isosceles triangle. This is 30 centimeters right here. This is 30 centimeters right here. Also an isosceles triangle. This leg of 50, this leg of 30, this leg of 30, this leg of 50, this leg of 50, and this leg of 30 and 30, 30, 30, 50, 30, 30, 50. These are congruent triangles. They're congruent triangles, which means they have the same area. That's good. If I find the area of one of these, it's the same area as the other. And if I add the 2 areas together, I know what this total area is. This total area, which is the sum of these 2 areas, taken away from the entire area of this rectangle, will give you this area right here. That's all in here. And that was where you got to kind of just watch out what the heck's going on. That's it. Well, the total area is going to be, and how you want to play it, how big is this thing right here? What is that? What's that h? Well, if that's h, it cuts it. This thing's 25.
That thing's 25. 25 and 25 is 50. This is 25. This is 25. Find this guy. It's the same length h. Let's just get one of the areas of these triangles. Then I'll just double it. I know what the sum of both areas are. I'll take the sum of both areas and subtract them from the entire area of this. This area is length. Forgive me. This area is length times width. 50 times 40, 2,000 square centimeters, minus double the area of one of the triangles. Let's get rid of units for a second. Don't worry about it too much. 2 times a half, that's where I blew it. I kept the half in there. 2 times a half is 1. The base is 50. You do got to find the height. Decent rendition of the height. Well, that's not too bad. I mean, if this is 30 and this is 25, you got a lot of things you can say. You got c squared. This is kind of important, guys. That's why I'm coming back to it. C squared equals a squared plus b squared. Who's who? Well, I mean, who cares? I mean, as long as the longest side is c, and that's 30, you can call this guy a, you can call that one b. Or you can just call it h. The longest side is 30. The a we'll call 25. The b we'll call h, so it's h squared. This is 900. This is 625. This is h squared. We've seen all this. I know we've seen all this. I just made one careless mistake, but that was enough for all of it to be wrong. Get h squared by itself by subtracting 625 on each side. Get the square root of both sides. And, like I said, to what degree we're going to do this, it's hard to know how they're actually wanting the answers reported, guys, so it makes it a little bit of a hassle. 16.583. All right, I don't know how far we got to go with this, but 16.583 might be enough. I mean, it certainly is enough. It's too much, but we're not going to worry about it. If that's what h is, let's put 16.583 right here. This thing goes out even further. Leave it on there with the further one on there. Multiplied by 50. So height times base times 0.5. That's the area of one of the triangles. Double the area of one of the triangles to get both of the triangles. That's 829.156. 829.156. So what you got here is it's 1170.84. What are they talking about? Centimeters? Good enough. Now let's see how they gave the answer at the end. I mean, there's a good amount of wheeling and dealing that we did with this thing to make it happen. Now we've already done this. I know that. If it looks familiar, yeah, it's supposed to look familiar. We already did it. They got 1170.8.
I got 1170.84. Who cares? It's good enough. It's fine. The interesting thing here is, guys, that's it. It's the end of the story. You could have played the game. Here's the beauty of the mathematics. That's the answer. Man, if I say I got a different way of doing this, that's fine. If I start getting different answers and the first answer was right and I get a different answer from the right answer, then that's a problem. Then that's a problem. Different way of doing it is not bad. Take this guy and make it into a trapezoid. Take this guy and make it into a trapezoid. You know, this is 40 right here. This is 40 right here. This is interesting. H and H are right here, and this is the difference of 40, subtract H, and subtract H again. It's 40 minus 2H. If you took H, which is this, and you doubled it, if you doubled H and H, you get 33.166. I hope. Let's make sure I did that right. You add it. Yeah, it looks okay to me. It looks like 33.166. I'm gonna go with that. If you double it to 8. Now, why did he do that? Why did I do that? Because this right here is 16.583. This is 16.583, and this is 16.583. 16.583 and 16.583 is 33.166. What is left over for you to get all the way to the top? This is a length of 40 all the way coast to coast. Coast to coast, it's 40. I got 16.5. I got 16.583 here, and I got 16.583 right here, and I got 16.583 right here. That's a total of 33.166, and I got to make the whole thing go to 40. Well, what's 40 minus the 33.166? That'll be that thing in the middle. If you go 40 minus 33.166, you end up getting 6.834. Let's make sure that's right. Let me just do that. Let me see if it actually happens. 0, 1, 0, 1 again, 1 here. Yeah, it looks okay to me. That is the middle. This is the middle thing. This guy right here, the middle. That middle is 6.834. So if this guy, if we're talking about this thing, you guys, if there's two trapezoids that are congruent to one another, and this guy's 6.834, and this guy's 40, if I can just find one of the trapezoids, if I just find this guy, this, and this, if I find this trapezoid, if I find the area of this trapezoid and I double it, if I find the area of this trapezoid, that's the same as the area of that trapezoid. If I just get this area and double it, I'll have the area of the entire entity that I want to find. Didn't we say that the area of a trapezoid is 1/2 base 1, which is the 6.834, plus the 40. This is one of the bases. This is the other base, times the height. The height is that. Well, what is that, actually? You're here. That's this guy. This is the 6.8. That's the 6.834 right here. To go right to the middle, if this whole thing is 50, this is 25 to go to here. This has got a height of 25 going that way. So what you got here is, you got 25. This is 25 across. This is 40 straight up. That's this. 40 straight up. So this is 40 straight up. This is 6.834. This guy right here is 6.834. This is 40. This is halfway across. All the way across is 50. So this is 25. And that's one of these trapezoids. I'm going to get an answer and then double it. Now, hopefully I did some of the arithmetic right. If this is wrong, it's only because I did the arithmetic wrong. That's still not a good excuse. It's still wrong. Now, we got that over there. I just want to show you, can this go another way to actually do this? Well, I don't know how far I need to go with some of this stuff, but let's see what happens. 6.834 plus 40 times a half is this, times 25 is that, and if you double it, 1170.85. Sounds good to me. This thing's 1170.85. When you got all this, this is just one of them. This is just one of them. The whole area is going to be 2 trapezoids. So multiply it by 2. I got 1170.85. What do they got? Yeah, they got 1170.84. We're not going to split hairs on that. What I'm trying to say, guys, is notice we added 2 trapezoids together. We found the area of one of the trapezoids and doubled it because they were both identical trapezoids in the sense that they were congruent. I found the area of one of the trapezoids and I doubled it, and that gave me all the shaded area. All the shaded area was about 1170.8. The other way I did it was I found the area of each triangle. They're congruent triangles, so if I find the area of one of the triangles, I just double that area and I have the area of both triangles. I take away that area comprised of the 2 triangles. I take that away from the area of the rectangle, and I still get 1170.4. Forgive me, 1170.8. So I want to show you there's 2 ways to do that. I figured it was a good time to show you 2 different ways to do it. It doesn't have to be done in one way. If you can accomplish the task with sound mathematics, then you can do so and you're going to get the right answer. There's numerous ways to get the right answer. If your mathematics is sound, your answer will be right. If your mathematics is not sound and you do it in different ways, you may get the same answer, but it might be the same wrong answer, or you might get 2 different answers. So if it's only one answer that's allowed, you've got to get the same right answer. And oftentimes, there's more than one way to do that. All right, guys. Thank you for I just wanted to go into that again. I just thought it was just a very interesting problem. So, okay, all the best. We got 2 more review tests to have done. We've done 6 so far. So, good deal.